here's the next section that we're going to cover now. This is actually section 2.2. Here we deal with graphs, as you can see. So here what we're going to see is we're going to look actually at equations in two variables, x and y. That's what we're going to look at. We're going to see what their graphs are. What does it mean to graph an equation? We're going to see what that is. We're also going to see in particular the parabola and the circle. There are other graphs in there, but those are the two I want to focus on. Okay. So now that's what I want to focus on. All right. Okay. All right. Now let's go on to this. So basically, you might ask first, well, what is a graph? Well, a graph is nothing more than a collection of plotted points in the Cartesian plane. That's all it is. A graph is just a collection of plotted points in the Cartesian plane. So for instance, plotting a single point like 1, 3, for instance, this is a graph. I mean, is it a graph worth studying? Probably not, but it's still a graph technically. Okay, still technically a graph. And yes, these are tied to equations in two variables. Now, how are they tied in? Well, that's where the next definition comes in. Well, not at first, but we'll see it eventually. Just like we had solutions to equations in one variable, we can consider equations in x and y in two variables. And then we could ask, what are their solutions? Well, a solution to an equation in two variables in x and y, by definition, it's an ordered pair of numbers, a, b, where if a is substituted in for x, a is the x coordinate, and b is substituted in for y, b is the y coordinate. If we substitute like that, we get a true statement. So we had equations in one variable, right? And solutions were numbers. Here we have equations in two variables. And the solutions are ordered pairs of numbers. The first number, okay, that corresponds to the x variable. The second number, b, corresponds to the y variable. And again, we get a solution if when we replace x by a and y by b, we get a true statement. So for instance, let's consider this equation, y equals 2x minus 1. Now, is 2, 3 a solution? Well, if we replace x by 2 and y by 3, if we substitute, we get this equation. And equations can be true or false. So here we do get a true statement. We have 3 is equal to 4 minus 1. So we do have a true statement. So it is a solution. What about here? 1, 3. Well, is that going to be a solution? Well, if we substitute 3 in for y, right? This is our equation, and 1 in for x, this is our equation. Do we get a true statement? Well, this is 3 equals 2 minus 1. 2 times 1 is 2. But that's not true. It's a false statement. So the right side does not equal the left side. Hence, this is false. So it's not a solution. And also, I threw in this point for fun as well. Is 0, 0 the origin? Is that a solution? Well, no. Because if we replace y by 0 and x by 0, we get a false statement. So basically, we want ordered pairs, okay, where if you replace x by the first number and y by the second number, in the ordered pair, you get a true statement. So we're kicking it up a notch, so to say, from, I think it was from chapter 1. What's nice about these equations, though, you can actually get infinitely many solutions. I mean, this is not infinite, but this is illustrating it, how you get more solutions. Namely, what you can do is you can let x be any number such that 2x minus 1 makes sense. And that's really any number. So if we take x to be -1, we calculate the corresponding y, and you can get a solution. So for -1, we would calculate the corresponding y value from this equation. We have 2 times -1 minus 1. That's -3, right? So y then is -3 if x is -1. Hence, this ordered pair is a solution. The idea, again, is we're replacing x by a number, and we're calculating, we're determining what the y has to be. We're solving the equation for y in chapter 1 sense. And so if x is -1, we're seeing what y has to be, and thus we get a solution. If x is 0, we can get y as well, right? We replace x by 0. 2 times 0, we get -1, we get y is -1. So 0 minus 1 has to be a solution, as you can see. Same thing with 1. And the idea is you can keep on doing this for infinitely many x's, and that's how you can get the graph of a solution, equation, excuse me. The graph of an equation in 2 variables, it's just the plot of all its solutions. You're plotting all the ordered pairs of numbers that are solutions to that equation. With technology today, like graphing calculators or what do you call it? Like Desmos, graphing programs, and GeoGebra, it's a lot easier to make graphs. But you still should know how to sketch a graph by hand. The whole idea is you're going to make a table like this, get a bunch of solutions, plot them, and then connect them by a smooth curve. When I say smooth, I mean something that does not do this, doesn't have any points or anything. Of course, the more points you plot, the better the graph's going to look like, the more accurate that is. But again, with things like Desmos, graphing calculators, makes it a little bit easier. Okay. That's what happens here. And a lot of times you can determine what the graph looks like. I mean, you might be able to know this is a line, but we'll see why next time. That's 150, so I guess we'll have to stop. Okay, we'll start. Okay, so discard. We'll actually start from this slide here next time.